Hey guys, so another video. I got my control cabinet cleaned up. I took all the drive. It's vector drive, servos, control boards, wires, three-phase transformers. Maybe you see it down there. Clean up the machine. No chips. The shop is drying out still. Humidity here is up to the roof. It's crazy here. I mean, the whole machine, I have to WD-40 everything to left it overnight, and still it's wet. So anyway, I wanted to touch this because I already posted another video on details on name brands, machine brands, building stuff, and there's some stuff as soon as you see them, they're gonna give you trouble. It's like my situation is like vehicles. You can see something, it's not gonna work mechanically. It's not gonna last. It's gonna work, but it's not gonna last. So on this scenario here is that gearbox. See, as soon as you go on YouTube, on Google or something, you type Haas Vf3, Vf2, the biggest problem that I found, it was gearbox. They noisy. I mean, loud. They leak. Alarms because the lubrication pump doesn't work. A lot of stuff related with that. And they do probably handy when you're maybe hogging like hard materials. You can get in low gear and maybe 1,000 RPM and do a 3-inch cut. I don't know, maybe a 1/4 inch deep. I don't know. I have no idea. I never done nothing like that. So maybe the gearbox works for some people. It's not my case. I'm not gonna get into that. If I ever got to do something like that, I'm probably gonna drop on my face mill, smaller face mill, a lighter cut, and get the job done. But so my idea is I want to get rid of my gearbox. My whole, spindle C-axis is gonna get lighter. A lot of stuff is gonna get out of the way. So I'm trying to go something for my research like a BF0 design. BF0 design, and they call that direct drive. So I'm gonna have the motor and a belt to the spindle, pretty much like my sharp here. This sharp is the same way. It's a 1-to-1 gear ratio, and it's got a 20 horsepower motor. It's got only one belt from the motor to the spindle. It's quiet. You can hear that machine, that spindle. The brothers, it makes a lot more noise than that machine does. And even on a heavier cut, what happens? Just imagine this, because I live this on these two machines. So that machine is so quiet. The reason for it is as long as you have a belt, just think about this. If you have a belt from the spindle to the motor, that belt is cushion, is absorbing all the vibrations from your cut, from your mill cutting on the metal, and it doesn't get to the whole frame of the machine and to the motor. So it's kind of taking all that vibrations and absorbing, cushioning that vibration from that cut. On the brothers, being a direct drive but sitting right on top of the spindle, as soon as you start getting it, a heavier cut, which this is still a lot smaller machine. The comparison is kind of high, different, a lot of difference, but still, even on a lighter cut, it makes a lot more noise. Even that, that red cover, which is the cover for that camera, the cover for the fan over there, you can hear it making a bell sound, amplifying the noise from the cut that you're getting from the down there, amplifying up there, because it's getting all the vibrations up to the motor. So having a belt in between the spindle and the motor is a really good advantage. This machine has it. I mean, from the gearbox to the spindle, there's a belt, but I don't want to have nothing in between. I don't care about the gearbox. And there's a lot less things I'm gonna have to worry about in rebuilding and all that. So what I'm gonna do, I'm gonna take the gearbox off, and I'm probably gonna take the motor and sit it over there. Now I also got an 8 horsepower Fanuc motor. I could sit that motor over there. It's an 8,000 RPM, 8 horsepower or 10 horsepower. I can also sit it over there. It would be nice because it has the fan on it already. You know, I'm thinking about it. But anyway, so that is one thing. I want to go direct drive on this machine. I'm not gonna be hogging, you know, on low gear or nothing like that. I want high gear. I mean high speed. So I believe this spindle, this machine, I believe, I'm not sure, I'm probably gonna have to get some, you know, VIN number. It's not called a VIN number. I'm thinking about cars, but anyway, something like that. Serial number on the machine, and find out if this is a 10,000 RPM or 8,000 RPM machine. I believe it's a 10,000 RPM because all the you know, when what I did was this. So I figured, you know, if they're 8,000 RPM, they're probably a 1-to-1 ratio, right, from the motor down to the spindle, even if the gearbox is in between. So it looks like there is different teeth gearing ratios for the gearboxes, and depending on that, that's how the machine was built, with different gear ratio, higher RPM spindle or lower RPM spindle. So I found out that this one is a 3/4 to 1 gear ratio. So this is an overdrive gearbox, if I can say it like that. Let me say it again. This is an overdrive gearbox. What happened is, for the spindle to do a full turn, just think about it, for the spindle to do a full turn, the motor only have to turn 3/4 of a turn. I already tried that out. I'm gonna try to do it on the phone with you here, and maybe you'll see it for your own. But it's an overdrive gearbox. It's not a 1-to-1 ratio. It's not a reduction box, reduction gearbox, like a lower gear. No, it's an overdrive gearbox. So I believe that's the way they made higher speed machines, like I think this one is. So this is, I would say, 99.9% in 10,000 RPM machine, because this is an overdrive gearbox, and I'm gonna show you how. Okay, so I wish I can put something on the spindle so you see it easier. Let me get a light, maybe you'll see better. Let me get a light here. We got light up there, but it's an ugly day. Ugly. It's humid. It's nasty. Let me see if I put this somewhere. Somewhere here. Because some dogs over there. Spindle dogs. Yeah. Okay, I'm gonna get up here. So you see, I got the dogs kind of line up to spindle orientation. Let me get this light closer, right? So they line up on X axis, right? Wait, I'm gonna move them. Let me see. Line them up on X just like they were. So what I'm doing here is they line up on X. Yeah, somewhere over there. Anyway, not perfect, but let me make it. something like that. So they line up on X, and I put me a wrench here. See an Allen wrench? You see it here, just to count, the turns on the motor, right? So if I turn this, a full turn, I'm overdriving because I'm in high gear, right? I'm overdriving the spindle, and I'm gonna show you how. So I got the dogs here. I'm gonna do a half turn, okay? And you can see here, the wrench didn't do a complete half turn, it was here in the middle, and it just went here to the side, right? I'm gonna do another half turn. Somewhere over there. And you're gonna see here that the wrench is not even on the middle yet. So we are around a quarter of a turn less than what the spindle is doing. So when I do, just for saying, if I'm here and I do one full turn, okay, I'm gonna try this, one full turn, and I gotta put the wrench to the front. My spindle did one turn and a quarter. So because my motor is a 3/4 to 1 overdrive ratio, just like pretty much like a vehicle transmission, like a car. Many transmissions, they're quarter turn overdrive. So this is pretty much what they done with this one. So this one is 100% now, but 99.9%. This is a 10,000 RPM machine, and since that is the case, I'm almost positive that is the case, because it is overdriving, and if it's not, I'm gonna make it a 10,000 RPM. So I'm gonna put that motor down there, and I gotta set up the pulleys. Why? Because the pulley on top of the spindle and the one coming out of the gearbox, they're 1-to-1. So if I put that pulley on the motor at a 1-to-1 ratio, I'm just gonna be an 8,000 RPM. So I gotta overdrive with the belt gears, or with the gear belts. With the gear belts. I gotta overdrive, so I gotta go, I believe this is a 44 teeth. I gotta go like to a 55 teeth, or maybe lower the front one to 32. Yes, I believe I gotta lower the one on the spindle to a 32 teeth, and then I'm overdriving because I got 44 on. I'm gonna have 44 on the motor. So that all depends what kind of pulley I find, and then that's gonna happen. So I won't have no gearbox on it. That's something I want to do. I'm just trying to point out things that I'm gonna get away from retrofit, things that I don't want to have problem later in the future. So I don't want my gearbox, so I'm gonna get rid of oil leaks, 2 solenoids, air control, a lot of stuff are gonna go out of the way if I go that route, right? And the other thing I'm gonna go with is I already got it. I took them out of the brothers, the stepper motors that I took out of the brothers, the NEMA 34, NEMA 34. I'm gonna put one here on the umbrella, carousel, whatever. I'm gonna put one to drive the umbrella, so that way that way I can control it easily, and just put on the macro, set up all of that. And I'm gonna take the other one too, the one that move the umbrella in and out, and I'm gonna put a pneumatic cylinder. It's gonna be easier to control, just one output, in and out, and and I don't have to worry about that motor burning out and burning, you know, a relay or stuff like that. So it's gonna be a pneumatic control, double action cylinder, and that way I'm gonna live with that better. So no gearbox, direct drive, overdrive on the motor. So I'm gonna overdrive the spindle, try to get more RPM. If I go crazy, I probably go higher RPM than 10. I don't think an old spindle like that, it matters. I really believe when the spindle is already broken and it's just, you know, it's just ready, it's all them bearings, they're already broken, I might take it out and, you know, and grease it. I don't know if it takes grease. I don't even know how it works, but so I might just take it out, grease it, put it back in, and you know, because I really believe, you know, when them bearings are broken already, and if it's so nice turning like that one is, I don't believe, you know, 1,000 or 2,000 RPM on top of whatever they build it for is gonna hurt nothing, depending on the cuts that I'm gonna be taking. But I want to go higher RPM, so I'm gonna overdrive the spindle the same way they did. I'm probably gonna go faster than that. Pneumatic cylinder for the umbrella to come in and out of the spindle area, and a stepper motor with a gearbox on the umbrella, the carousel, to turn it, you know, back and forth. So that's it. I got a bunch of stuff here I took out. I don't know, these boards, they look beautiful. I don't even know what this is, but that battery was probably giving me some trouble. And this one is some kind of, well, this is where the encoders and all the stuff they were connected to. This board right here, maybe good or bad, I don't know. But I had some codes, some alarms, but none of them were related to what I think this. And this another board, it's got some big microprocessors over there or whatever. So anyway, I'm gonna try to list this, see if I can get some money out of it. Whatever I get, I'm gonna be happy with. I really don't care about this. They're just gonna be sitting. They're just gonna be sitting there. Probably throw them away, but I'll find a way to, you know, make someone happy with it. There's a good power supply here, which I pulled out. This one. There's another power supply, which I don't think this one is very important, or maybe this is the important one and not the other one. I don't know. I can't see nothing. Let me get my glasses on. I don't know. This one had power to it. It had a bunch of stuff connected to it. And this output control board, I don't see nothing burning on it or nothing bad, so maybe it's good. It was clicking those relays and all the lights were on, so maybe that's a good one. And that vector drive, spindle drive or whatever, I'm gonna get rid of it too. I'm probably gonna post all of this on eBay or something, just sell it for something. Hopefully I get, you know, a little bit of money back out of whatever I'm gonna spend here. So whatever I get is plenty. Well, that's it. Direct drive, no gearbox, stepper motor, and pneumatic cylinder for the umbrella, in and out. That's gonna make my life easier, and that's it, guys. So I'll see you then. Did I show you? I'm not gonna look back on the video now, but yes, I did show you control cabinet. Yes. So yeah, really clean, nice. It's gonna come out good. All right, guys, have a good day. Those are new tips. Overdrive on the spindle, that's the way they do 10,000 RPM. Good day, bye.